the chance of either keeping you awake or get you out of the rooms. Because, as you were saying, lunch is not an easy thing. Now, let me see if I can keep you all awake as much as possible. In fact, the title that was read is not exactly the one that I have here, because yesterday, Sumantra called me up. He said, Seshu, sir, can you make it a little more generic by talking more about the technologies that have something to do with the mobility? He said, the opportunities, the advantages, the benefits, and the hurdles of new mobility technologies is what he wanted me to speak. So I said, let me do that. Now, I could as well talk of many other things as well. One of the people who probably have driven an autonomous truck in 1993, I don't have the picture here, but I was one of the guys, not driving, but sitting inside. It was from a small little town called Ulm in southern part of Germany to Stuttgart, which is the Mercedes city, and the truck was naturally a Daimler truck. The whole truck, that was a 16-ton truck that had batteries and control electronics, 8.5 tons. Now, in today's truck, in today's passenger car, the same equipment is probably not more than less than a ton. Now, that has been the progress. Now, the progress in mobility that we have seen in the last 20 years is enormous, mind-boggling, and fascinating at the same time. Now, let me take you through today. I will take you through about 8 mobility technologies that I believe that are transforming the way we move and commute in the next years and starting right now. And I will talk about 4 combined opportunities and chances for us, and also talk at the same time about the hurdles that these technologies may come across over the time. Then we do a kind of a reality check, which is what basically a topic that lies close to my heart. In fact, I would have wanted to speak on that completely, but then Sumantra came in between. So I had to restrict myself to what I'm presenting right now, but I took the freedom towards the end to talk exactly what I wanted to talk. Now, these 8 technologies that I'm talking about are electric vehicles, autonomous vehicles, shared mobility services, mobility as a service. These are not products, but these are technologies. There could be products coming out, there could be services coming out, there could be whatever coming out. Now, Hyperloops is one of them. The EV tolls. Then we talk of the intelligent transportation systems, then mobility and transportation applications. Now, they all revolutionize the way people move and commute in future. They have a potential in future to improve efficiency and sustainability for this world. Now, let's look at the electric vehicles. We all know electric vehicles use battery. Well, they use sometimes something else as well. For now, being a generic presentation, let's concentrate only on that they have some kind of a storage which is used to run a vehicle. Now, they have an enormous potential to reduce our dependency on oil imports and fossil-based origin technologies. They also could actually help us at some point or other to become completely sustainable. The day we make batteries based on some kind of a renewable energy. Today the electric vehicles are not yet sustainable. Depending on which kind of calculation you see, it could be 80,000 kilometers to 100,000 kilometers, where an IC vehicle can be probably overtaken in terms of its sustainability footprint. Now, when I talk of electric vehicles, we talk of electric cars, electric buses, electric trucks and scooters and bikes. You may have seen down there one picture, you also have these pantograph kind of charging. They use some kind of capacitors probably, or LTO chemistry, for kind of flash charging. So we talk of generic electric vehicles. These 2 pictures you see there are the ones that I've actually been working for the last many years. Volta Zero is a Swedish company that I was a director and investor for quite some time. And the second one you see on the left side is my baby. That's called CityQ. It's a Norwegian-German company. This is supposed to transform the urban traffic, as we see. We will talk about in a few minutes. Now, autonomous vehicles is the second one. They sometimes are also called self-driving cars. This is, by the way, future music. When we talk of self-driving cars, we don't mean driverless cars. They do lots of functions on their own. Driverless vehicles are something that are right up there in the so-called SAE classification that people talk about. But for now, let's call them autonomous vehicles that actually do quite many functions on their own. They actually have the ability to reduce quite many accidents. I can tell you, when I was a young engineer in Daimler-Benz in Stuttgart in Germany, I'm talking about my early days, I was one of the first guys to develop what we called in those days a distance warning signal sensor by measuring Doppler frequency between the vehicles. That was easy in those days. We had a big antenna, a C-band antenna at 5.3 gigahertz. It is such a big dish. And we brought it down to 18 gigahertz someday. It was so small. Today, you can buy such a radar for $10, right? So that's what the technology improvement is. But the base of everything is to measure the distance so that you can give this information to the brakes and whatever, so that it applies brake. That's too technical, but that's what actually is the beginning of everything. Now, today, you see them. You've got 360 degrees. You've got sensors like optical sensors. You've got LiDARs. You've got radars. You've got acoustic sensors. And that give you safety 360 degrees around the car, while driving, while parking, while parked, everything. Now, you also have technologies like GPS and 802.11p's, the wireless technologies. Now, what do they do actually? They reduce accidents. 85% of the accidents happen because of human errors. Now, how can you help them? We don't have the ability to do parallel processing as much as a machine has. So these machines, with all kinds of sensors, using a bit of artificial intelligence right now, they should be growing more and more. Things that you cannot see. We worked on some of the projects where you see half of the object. For example, we took a child walking on the pedestrian zone, and would the child come onto the road? Now, you see the child walking between the cars. You get him only for a few short milliseconds, but then you would track his trajectory to find out. That's an artificial intelligence. You project, would the child come to the road? Now, again, so they have a lot of ability. They have a lot of ability to actually help you in reducing accidents, but also they can optimize the traffic flow. And the overall efficiency goes up. The next ones, we talk of the shared mobility services. On the right side, you see the so-called combinations of, the classifications of shared mobility, like membership-based ones, peer-to-peer. But on a top level, they actually reduce the individual ownership of the vehicles. So with probably 100 vehicles, you can replace more than few thousand individual vehicles. Shared vehicles actually give you an optimized resource utilization that exists right up there. So you can see here, for example, they also reduce traffic congestion, lower carbon emissions because of that, and improved resource utilization. Now, on the right side, you see this is actually meant for people who typically want to look at later on when the presentation is available, is that you have to classify those services for some of the entrepreneurs to start offering services for people. Now, the next one is mobility as a service. This is not anymore a future thing. It's already available. For example, when I came this week from Germany, I bought an air ticket that included train, a bus, and a tram from my home. All the way, what they could not get me, naturally, is a drink in between, unfortunately. The flight has a drink, but not the bus. But I could as well have opted for a bicycle instead of a tram. That would also be possible. Now, what they also could not offer was, although hotel was part of it, I could have booked a hotel. Now, you see what's happening here. Now, all I need is just one app to do all of them, which requires a lot of background work because these companies have to talk to each other, they have to standardize the services, and the details are known to all the experts sitting here. Now, they have an enormous potential to change the way we travel in future. The next one is, is the Hyperloop, which is actually supposed to be my original talk. Now, there's a first mile, there's a last mile, there's an in-between miles. These are actually typically longer ones, intercontinental to intercity, interstate, intercountry, whatever. Now, Hyperloops do have the potential to help us reduction of the air traffic, which is otherwise a polluting transportation medium. Now, these Hyperloops, as they say, they have because they have the ability to get you to near supersonic speeds, which naturally means that they can't be running on tracks. They can't also be running on tires, right? They will require very special medium. So you typically can imagine, lots of tunnels, lots of tubes that are almost like vacuum, like space, like, they suck out the whole air. Well, they're almost like a space, but not exactly. And these pods that could consist 10 people pods to hundreds of people, but not more than few. The debate is on. Can you have 100 more? Well, we'll see. Now, what typically happens here in the Hyperloop technologies is it levitates. Magnetic levitation is the one that people require. So you require big stators and big magnets to levitate them, and they go at a speed of 900 miles to 1,200 miles possible at some point or the other. So these are some of the technologies that are going to change. So we talked about the first mile, we talked about the last mile, now we talked about the middle mile. Now there are other ones as well that are going to change. How many minutes do I have? Can anyone tell me? Time is out. Okay, just give me 2 more minutes then. Now, I will have to move a little faster here. So we've heard with a presenter that presented just before me on this, so I won't go there. I have to show you something which I really came for, so I have to skip. I'm sorry. Now, so, if you add up all the individual promises given by the governments worldwide, we are nowhere near 2 degrees. We'll be crossing 3.x degrees. And we all know this is a one-way road with no chance for U-turns. It's a disaster, pre-programmed more or less. Now, what does it actually mean? The South Market in San Francisco will be underwater. Havana in Cuba will be completely underwater. Now, the famous White House is underwater. Now, this what will happen about 2 degrees to 2.5 degrees. At 3 degrees, you can go to internet and check those, things, how cities would look like. Now, road transportation is approximately 25% of it. And houses and others, there are many more. But interesting point is, now, it's not just emissions. It's about congestion. This is a modern curse. Now, we have just crossed 8 billion people, 1.4 billion vehicles on the earth. Now, imagine there's 6.6 billion people start moving to these big vehicles that we have. I think it's a dead planet. We call it no plan B, no planet B. We've got, for now, just one planet. So that's what is going to happen. So what we need to be doing is to look at not just batteries and so on. We also have to look at traffic congestion as well. This is a much bigger problem, which we are not concentrating. That's absolutely important to look at. Now, you look at here, diesel cars, hybrid cars, electric cars, they're still produce the same thing. They do not answer all the problems. Now look at here. These are all the problems. Space pollution, only 200 passengers per hour and lane are possible. Now, noise pollution, after a certain speed, it's no more the engine that gives you the problem, it's actually the friction between the tire and the road. That's what actually gives you the noise pollution. Safety, you can kill with electric vehicle also people. Right? So it's not going to change much. Particles, the tire friction produces so much of, they're deadly particles out there. They are not going to change because we've got electric vehicles. Inequity of the space. I want inequity of the space, let me show you. That's inequity of the space. Or you look at this one. Something needs to happen. I have some solutions for it, but I think we'll leave it for next time because my time is up. Thank you very much for the attention.